Hello everyone. Welcome to the questions session of the second week. This is the first question session in which we will look at a few questions based on the first lecture of this week. Here are a few questions on your screen. List about 5 different commands that are installed on your desktop operating system. We are a bit categoric here that please you look at your desktop operating systems. In contrast, do not look at your mobile operating system, for instance. For each of the command line programs that you see on your operating system, list out the advantages and disadvantages if they are designed as interactive programs. This question is about interactivity. The second question is again on the same curve, same as the first question, except that it considers the issue of non-interactivity. If those same commands that you have listed in question 1, if those same commands are non-interactive, or suppose they behave non-interactively, then what would be the advantages or disadvantages? These questions are meant to get you thinking about aspects of program design. We also have a hint, a suggestion, an idea about how to go about for questions 1 and 2. Consider the interesting ways in which a user would use the program. Our example is file copy program. Well, please note, if we are using file copy as an example, right away, then a file copy program will not be a part of your list of 5 programs. Let me repeat. We are using the file copy as an illustration in this session, so a file copy should not be an example that you list out. Okay. Suppose your operating system, Windows, GNU Linux, Mac OS, whichever it is, it will typically have a command line version of a file copy program. Consider the scenario when a user has to, say, copy a huge number of files, say 1,000. Would a interactive way, suppose the file copy program were designed as an interactive program, would that be an advantage or a disadvantage in this case? The case when the user has to copy a large number of files, say 1,000 files. Would a non-interactive version be more advantageous? In what case will a non-interactive version of this problem be a challenge? The third question gets you learning about using the standard input, output and error devices of your system. The default devices are keyboard, monitor and monitor respectively for input, standard output and standard error. What other devices can be used instead of these default ones? Try to find that out for your operating system. The fourth question, the sample command line program used in the video lecture is a correctly working program. It is correct in the sense that it performs the necessary calculations correctly. It works in the sense when the user gives the correct user commands, it performs the correct operation corresponding to that command. However, it is not yet a software product. This question asks you to list at least 3 distinct improvements in the command line version of the program that will make it a software product. Note that the program must remain a command line program. So An improvement which says convert this program into a graphical one is not something that we are looking for. Your program will remain a command line program, but nevertheless become a software product, which it is not right now. The fifth question: develop a detailed proof of correctness of our method used in the fair share program. Try to ensure that each step has one and only one clear change from the previous step. For each step, be sure to note the reason behind the change that you did. From our experience, we know that you may have to repeat this exercise a few times to get it right. The idea of this exercise is to have a step-by-step reasoning about the correctness of our program. Usually when we think about things like this, we very quickly jump to conclusions. This exercise is meant to take us step by step, with every step justified by some reason. That is why it will be slow, and you may realize that you have forgotten some steps in the version that you wrote, so you may have to rewrite it again. The next question. The command line program we have used in the video lectures illustrates an important principle of design of user interaction. The information must be displayed consistently with any required conversions between internal and displayed information. Recall that when we displayed a report, when a roommate actually owed some money, then we said that that particular roommate, the amount owed is minus some number. We also remarked that negative values are our internal understanding that they represent the money to be paid. But when you display that money to be paid as a negative number, and moreover saying that this is the amount owed, a typical user is very confused. It is very important to be consistent in the way the information is displayed. This is the principle that we did not do well in our program. This question asks you to list out few other such principles that you may recall from your studies. The seventh question. The fair share program can be written in procedural style as well as object-oriented style. We suggest that you write the program in both the styles. That way you will understand the differences and the advantages between the two styles. Therefore, this question asks you to write in the other style than the one that you have written. If you have written in an object-oriented style, then this question asks you to rewrite the program in a procedural style. If you have written it in a procedural style, then this question asks you to rewrite the program in the other one. The eighth question. The arrays in our program are indexed using numbers. For example, the money spent get indexed Abhijat is 200, where get indexed Abhijat returns the index, the integer, the number against which the money spent by Abhijat is stored. It would be nice if we could index them directly using the names of the roommates. So instead of saying money spent by get index Abhijat, it would be great if we could write it as money spent by Abhijat. This exercise just asks you to suggest an algorithm in Java how this could be done. Of course, if Java has any facilities, then you may not use them. You have to write the algorithm independent of Java approach. Ninth question. Our program used a certain invariant to ensure that it will be correct irrespective of the number of roommates. Can you adapt these ideas to design the core calculations of an accounting software? You should of course identify the invariant for accounting and demonstrate that your calculations will work irrespective of the number of accounts and their interactions. In this question, we try to take our understanding of the invariant and correctness ideas for the fair share application and apply it to an accounting problem. There are many ways this can be discussed. We hope that you actually use the forums to discuss questions like these in detail. This question not only requires you to change Java, not only talks about implementing code, but also about thinking ideas from one problem that you have solved and applying them to another problem. The last question. Our implementation has made a simplifying assumption. Only one roommate pays for a given event. Suppose we now discard this assumption and allow more than one, and possibly all, roommates to share the expense for an event. Note that the sharing may not be equal, but will always add up to the expense of that event. So if more than one roommates share, then they don't have to share equally. One roommate may spend a little more than the other roommate. It's possible. How will our invariant change if it does change? How will our calculations, especially of the per head share, change? How has our invariant helped us to guarantee the correctness of our calculations? Apart from programming exercise, we suggest that you also try to answer these questions for yourself. Of course, you are welcome to discuss them on forums. At various points, we will give hints of the solutions. Thank you.